So far in this unit, we've been talking about moles, and we've been talking about the relationship of moles to other quantities. So we've talked about how moles relate to representative particles. And remember, this could be several different things. It could be molecules, could be atoms, could be formula units, could be ions. And that's about it for this class, but it could be other things in different chemistry classes. We've talked about how moles relates to the mass. And remember, it is the molar mass. And the molar mass, an important note, the molar mass is different for every compound. Remember, the molar mass depends on what elements are in the compound and how many are there by number in the formula. And then the volume of a gas, which is specifically at our conditions of STP, and it was 22.4 liters. So these are our three basic quantities that all relate back to moles. In order to simplify this, we're going to draw a picture here. It's what I call figure 1. This is a diagram that shows up in every Chemistry 1 textbook that I've ever seen. So we're going to draw the diagram to show how all of these quantities are related. All of these relate to moles, and so right here in the middle, I'm going to put moles, and I'm going to put it in a box. The first thing that we talked about that relates to moles was our representative particles. So here it is over here to the bottom left. And you're going to want to pay attention to your arrows and the conversions that I draw. Make sure that you don't get them reversed. So here are my two arrows. We could go from moles to representative particles following this arrow, or we could go from representative particles to moles following the other arrow. So when we are going from moles to representative particles, there's a specific relationship. When you start with moles, 1 mole should start on bottom. And it's a specific number. That's Avogadro's number. That's going to go on top. When you are following this arrow, this is the conversion factor that you want to use. If we're going the other direction from representative particles to moles, we're following this bottom arrow. We want moles, so 1 mole should be on top of the conversion. And our number of representative particles should be on the bottom. So whenever we're going back and forth between these two things, it's a dimensional analysis question. But that's not the only unit that we know that connects to moles. The second thing we talked about was mass. Again, you can go back and forth between either of these quantities. So let's be careful with the arrows. Let's draw one this way, and let's draw another one this way. When we are starting with a number in moles and trying to find mass, we are following this arrow right here. And the conversion factor, when you start with moles, you have 1 mole on bottom. And then on top, the number of the molar mass. remember, the molar mass is different for every compound. You have to look at your periodic table to find the atomic mass, and you have to look at the formula to find the number of each atom. Look back a few pages, you'll see that, but it's different for every compound. If we start with the number in mass, and we want to know how many moles, we are following this arrow. And if we want moles, 1 mole will go on top, and we are dividing by the number that we call the molar mass. Now it becomes useful because if you happen to know the mass of a sample and you want to know how many representative particles are there, you can figure this out. Like, let's say, for instance, I have a penny, and this penny will say it's 100% copper, and so we first have to go from mass to moles. You have to follow the arrows. Look, there is no way to go directly between these two, but you can go to moles and then to where you want. And so we would divide this mass by the molar mass, and then we would multiply the number of moles times Avogadro's number. We follow the arrows, and it'll take us to any of these other places. But the third quantity we talked about was volume. So volume, and let's specify at STP. Here's the volume at STP. We can go from moles to volume along this arrow, or if we knew the volume, we could figure out moles by following this arrow. Going from moles to volume, we need moles on bottom, and we know the number. It's 22.4 liters. So here it is, 22.4 liters over 1 mole. If we were to measure a volume of a gas and we want to know it in terms of moles, 1 mole would go on top, 22.4 liters would go on bottom. So from any point on this diagram, you could find any other value. So let's say we know the volume at STP, and we want to know what is the mass. And so what you would do is follow the arrows. I know volume relates to moles, and I know moles relates to mass. We just follow the arrows and we pick the appropriate conversions. Let's say you have a number of representative particles and you want to know the mass. So representative particles to moles, here's the conversion to use. Moles to mass, here's the conversion to use. And this is just a nice, easy diagram to help us convert between these 4 different values.